Up next, we have Sarah Sondag from Minnesota DOT. Sarah is a bridge preservation engineer with the Minnesota Department of Transportation.
Thanks everyone for the opportunity to present today. Good afternoon. Like Scott mentioned, my name is Sarah Sondag. I'm with the Minnesota DOT in bridge preservation and operations support. One of my main responsibilities is working with our bridge maintenance crews, working with training, best practices, data tracking. So today I'm going to talk a little bit about performance measures, specifically bridge maintenance performance measures. But before I get into that, I'll talk a little bit about Minnesota's bridges and our data tracking process. So Minnesota defines a bridge as 10 feet or greater. MnDOT owns about 5,000 bridges, and the remaining 16,000 are owned by over 200 local agencies. We're a decentralized state divided into 8 districts, and we have 20 in-house bridge maintenance crews within those districts. And they manage the inspection and maintenance of the bridges. So talk a little bit about the maintenance process, maintenance data tracking process. So we identify needs through different mechanisms, through our routine inspections, through maintenance assessments. Typically after we flush a bridge in the spring, it's a good opportunity to assess that bridge, assess the joints for damage. Also through condition data. I'll talk a little bit later about within some of our elements we've defined the condition state language to make it easier for bridge maintenance supervisors to query certain tasks. And then also through recurring preventive maintenance schedules. And then once those needs are identified, we enter them into our maintenance management system. And then once the work is accomplished, we'll track that data in our maintenance management system. Typically, bridge maintenance is accomplished by our 20 in-house bridge maintenance crews. Some is also accomplished through contract work. Typically, we use contractors when the bridges might be difficult to access due to traffic or other factors, or possibly when we need to supplement resources. Like I mentioned, once that work is accomplished, we'll track that accomplishment within our SIMS maintenance module and our timesheet. And then we tie those costs together in a data analysis tool called Oracle Business Intelligence. This is just a screenshot of the data tracking form in our SIMS maintenance module. SIMS stands for Structure Information Management System. It's a Bentley AssetWise product. And it's a configured bridge maintenance task form. And we specifically use it for planning, scheduling, tracking, and reporting our bridge maintenance needs. There's a lot of different fields on this form. You can see the top portion is really just the required, and we look at tracking that data by bridge, by activity code, by a description that the work crews can use to actually perform the work, by priority, and due year. And then once that work is accomplished, we'll track the completion dates. And for that, then we can tie it back to our timesheet management system to identify labor, equipment, and material charges, and then get a unit cost. We also track our maintenance activities by element, and that kind of allows our system to track accomplishment and tie that back to the original deficiency from the inspection side. It also gives us an opportunity to look at benefit. In Minnesota, we define preservation as a program of cyclical and condition-based maintenance activities that are performed to keep bridges in sound condition and slow their deterioration rate. And then within that definition, we define preventive and reactive maintenance. Our preventive maintenance is defined as routine activities typically performed according to an assigned frequency, but also on an as-needed basis, really to slow deterioration. And then reactive maintenance is performed in response to an identified condition. Within our reactive maintenance category, we have 3 different priority levels. Actually 4, I'll talk. There's also a critical priority reactive maintenance for our activities that need to be accomplished prior to 1 year. But so our high priority reactive maintenance needs to be accomplished within 1 year. Medium priority needs to be accomplished within 3 years. And then our low priority activities are in response to conditions that don't have an impact on structural function and can be deferred greater than 3 years. So now I'll talk a little bit more about performance measures and how we identified our bridge maintenance performance measures. Traditionally, bridge performance measures focus on overall condition. They're established to manage bridge performance. They also promote investment strategies that are aimed at achieving that state of good repair. And maintenance performance measures can help to prioritize that maintenance with the goal of keeping bridges in good condition longer. So we have performance measures for both reactive maintenance and preventive maintenance. I'll start with the reactive maintenance first. Reactive maintenance is divided into those priority levels, and we look at completion rate. So we look at percent completed on time, or that's within 1 year for high priority reactive maintenance, and the target is 99%. And we have been tracking that for a number of years, and we typically can hit that 99% target. The second two performance measures, medium priority and low priority, are under development still, and we are looking at reducing the backlog of work. We haven't set the target yet. Possibly in the future, we will also focus on some specific reactive maintenance activities, especially for those that are related to deficiencies that might cause accelerated deterioration. For example, I show a drainage system. So typically on where a drainage system is connected, if it fails or if it's leaking, then you'll have accelerated deterioration to those elements. So it's tracking that, making sure that that drainage system is functioning appropriately. This table, now I'm transitioning into preventive maintenance. This table shows a list of typical preventive maintenance activities that our MnDOT in-house forces perform. Many of these activities, I think we heard Justin talk on the first day about preservation and the importance of not just the activity but also the timing, right? And so for preventive maintenance activities, it's not just even the timing of the initial activity, it's also that recurring, right? It has to be performed on a recurring basis to be effective. Of these, we identified 4 areas that we wanted to track with maintenance measures because they're identified as being effective and they should be tracked more officially through a performance measure. Those are flushing, sealing, pore joint sealing, and gland repair. So these are the 4 measures. I'll go into each one in a little more detail. The first 3, flushing, crack sealing, and pore joint sealing, are also based on completion on time. The 4th is based on condition of expansion joints. For flushing, we have a recommended frequency of annually or as often constraints allow. And for Minnesota, flushing is defined as applying a high volume, low pressure water to the structures to clean them. For the performance measure, we're looking at completion on time, so percent of bridges that were flushed annually, with a target or level of service A of 95%. So we have a list within our SIMS maintenance module that shows the bridges that are required to be flushed, and then the crews can check those off as they are flushed. We do have some exclusions, so we focus on state-owned bridges. We exclude culverts, railroad and pedestrian bridges unless they're historic. And we also include timber deck structures and bituminous wearing surfaces. The target is set at 95%. Most of our outstate districts can hit that target, but constraints within the Minneapolis-St. Paul metro area make it more of a challenge, especially with traffic and access, make it more of a challenge for our metro district to achieve that. And so we look at then breaking that metric down into priority goals so that we're focusing our resources where they're most effective. So priority 1 are flushing the bridges with modular joints or post-tensioning and flushing those annually and assessing them for leakage. Priority 2, flushing bridges with joints above piers. Because we know leaking joints, right, can cause some of that underlying deterioration, so we want to focus on those areas. Priority 3, flushing remaining bridges with joints every 2 years. And then flushing bridges without joints every 4 years. Crack sealing. Our recommended activity frequency for crack sealing is 3 to 5 years, and that's based on a research project that we performed in the report, I believe, was dated 2014. And we did evaluations, and that's what the crack sealing products were lasting for about 3 to 5 years. So for the performance measure, we're looking at 5-year frequencies. That's the typical frequency that our crews will use for resealing. So we're looking at the percent of bridges crack sealed on time by square foot of deck area. And the target again is level of service A, 95%. To identify the bridges that are included in the measure, we look at state-owned bridges in good and fair condition with a concrete wearing surface, and then we use an agency-defined element to determine if cracking is present. So in Minnesota, we don't use defects, and so we define an agency element, and it looks at the extent and severity of cracking. So we use that element to help us identify which bridges should be included in this measure. And then the sealing history in our maintenance module and also in our timesheet system is used to calculate that percent. We also look at if there was any sealing performed by contract, that's also included as a completion. And then if there was a deck project that may have precluded sealing within that time frame, then we'll remove it from the measure as well. For pore joint sealing, similar to crack sealing, the recommended frequency is every 5 years. That's based on how long the materials last, but it also is based on coordinating those activities. So a lot of times when a crew will go out, they might perform multiple activities on that bridge. So if we coordinate those schedules with crack sealing and pour joint sealing, it helps with accomplishing that work and minimizing traffic closures. Similar to crack sealing, we're looking at the percent, but it's by lineal foot of poured joints sealed on time every 5 years, again with a target of 95%. Eligible bridges are identified within the system from bridges that are state-owned, those in good and fair condition, and then we look at element 301, which is for our poured joint seals. So any bridges that have a poured joint seal on the bridge will be included. And this is one of those elements where we redefine the condition state language to help us with querying maintenance tasks. And so condition state 3, I'm not sure if you can read it well on the slide or not, but condition state 3 means complete adhesion failure. And so that means we need to reseal that joint. So they can perform a query of condition state 3, and that means those joints need to be resealed. Whereas condition state 4 is more on the lines of joint reconstruction. So it helps us kind of make it a little bit easier to query those tasks. For crack sealing, I mentioned for flushing, most of our outstate districts could meet that measure. For crack sealing and pour joint sealing, we're not quite there. Some of our districts are hitting the 95%, a little bit lower in some other districts. And I just wanted to emphasize that the point isn't just to point out who isn't meeting that measure. The point is, where do we need to assign our resources? Do we need additional resources here to be able to accomplish this work? If we're identifying this as important, critical work, we have to figure out where we need to put our resources, right? For looking at the measure, again, we look at the sealing history in our maintenance module and in our timesheet system. And we exclude any bridges that had a deck project within that time frame. The expansion joint maintenance and repair is a little bit different because the recommended frequency isn't on a recurring basis as needed. So if you have a gland that's torn or a gland that's pulled out, then you need to go attempt that maintenance, but we don't always know that when that might happen. So then our measure is focusing on element condition, and we want to limit the lineal foot of strip seal and modular joints in poor and severe conditions. So we're hoping for that 95% in good and fair. Again, similar to element 301, element 300 is our for strip seal joints, expansion joints, and then 303 would be used for modular joints. We identified condition state language that helped make it easier to query the data so that you can assign specific tasks or look at specific tasks. So condition state 3 is focused on gland repair and gland replacement. So our crews can then query their list and go out and see if they can accomplish a gland repair within that location. They might be able to patch it, they might be able to separate out a section and add a new section of gland in there, or replace the gland fully. And then for condition state 4, it's joint reconstruction, which is typically performed under contract. We have had some crews replace joints, but it's typically performed under contract. But that also makes it easier for our scoping engineers to identify those bridges that do need a joint replacement. Similar to flushing, we split expansion joints out into priorities. So again, focusing on those modular joints for priority 1, focusing on joints located over piers again, trying to limit the leaking over underlying elements that causes that accelerated deterioration. And then third priority would be expansion joints not located over piers. And I put this slide in here, it's a little bit of a departure, but I think it's related because when you're looking at measures, you're looking at effectiveness of activities, and to really have an effective activity, right, we need to be consistent, we need to be performing the activity appropriately. And so we have a pretty robust training program. We have a Bridge Maintenance Academy. Academy 1 are a series of e-learning modules, starting with components and elements, loads and forces, plan reading, all through materials. We're actually under development for some of these, so they're not all out there yet. Bridge Maintenance Academy 2 and 3 are week-long hands-on courses that are open to state forces and local agency forces. And within those, the participants are given the opportunity to use different materials, work with different equipment, and work with different techniques. And then we also have e-learning modules that are focused on our preventive maintenance, flushing, crack sealing, pour joint sealing, and gland repair, which are also our performance measures. So we have e-learning modules that go into prep planning, equipment and materials, safety, environmental concerns, and best practices for each of those activities. And those are available on our external Bridge training site. Next steps are to report on these new preventive maintenance performance measures. This is our first year we'll be reporting on those. We want to identify some of those performance gaps and identify the cost to achieve that target of 95%. And also to assist with achieving these targets, we want to develop some more tools for the districts, some more reporting tools and work planning tools. And then promote that data tracking best practices. I think it was talked about in one of the peer exchange sessions, right? It's only as good as your data, right? So you have to have accurate data to be able to report on these measures. And so we want to promote the best practices for tracking that data and reporting that data. We're also working with Bentley to integrate a maintenance scheduling, a recurring maintenance tool within SIMS to make it easier for us to just automatically schedule those maintenance activities within the assigned frequency. Implementing some more repair and programming strategies to reduce expansion joints in poor and severe condition. So we're actually taking that joint data, we're integrating it into our bridge management system so it's easier for the scoping engineers to see and identify that there are joint repair projects that are needed. We just started a research project to look at our bridge maintenance data, our construction history, and bridge characteristics to try to identify or actually quantify benefits of some of these bridge maintenance activities. And so that will be accomplished hopefully in 2023. Identify any additional performance measure needs based on that research study, and also through, like I mentioned, some of those reactive activities with deck drainage systems. And then finalize MnDOT's bridge worker formula. Basically what that is, it's a mathematical method to attempt to quantify staffing needs based on different types of factors. So we look at ADT, we look at distance to the bridge and other different factors to try to identify those full-time equivalents that are needed to actually maintain our system. And with that, thank you. I'll take any questions if there's time.
I think a performance measure, I thought that it is basically how effective the actions are. So I was thinking that presentation will be on that part. Second thing is, mean time to repair is a good performance measure, I agree. But at the same time, mean time to failure also need to be captured.
Could you repeat the second part? What
mean
needs
time to failure means
mean time
whatever defects you observed, again when it happened.
A lot of our measures right now are focused on the preventive maintenance, and like I said, we're in conjunction, we're doing that research project to identify which maintenance activities give us the most benefit, and then we might revamp some of these performance measures. But we feel that preventive maintenance are key to actually keeping our bridges in good and fair condition longer. And so we want to track that they are performed on a cyclical frequency. And then we also, in conjunction with training, we're promoting the best practices on how to perform this work so that we do get quality performance out of these types of actions. Does that answer your question a little bit?
Partly, yes. So that part, I don't know how you are going to capture that.
Well, we're starting a research project to try to capture effectiveness, and we're looking at our data, our past maintenance history, we're looking at bridge characteristics and construction history, and identifying the effectiveness of each of these types of activities. Right.
I have a question about the performance. Actually, we are thinking in Texas about two facts. First is material performance. Different material performance, different. Also found the contractors' construction practice also affect that performance. So you have any suggestion how do we differentiate or try to contract? Because some could be good products, but the contractors use it right. So that's very hard.
Yes, it can be a challenge. There's so many factors that can cause or that can affect quality. I think it can be a challenge. I think in some cases, some agencies will use like mock-ups or trials within their special provisions that a contractor needs to, or demonstrate that they have experience in certain types of activities. We're also implementing bridge trials tracking. So every trial that we perform, we want to be more consistent on how we're tracking that so that we can make better decisions on if we're going to continue to use a certain technique or a certain product. And so that's, I think, another, whether it's performed under contract or within our maintenance forces. And so we're kind of developing a new process for being more consistent with how we track trials and make decisions for the future.
Okay, thank you so much, Sarah. Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.